Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon, ladies and gentlemen. Welcome back to my channel. In this video, I would like to showcase a project that I'm going to deploy in a laboratory. So this is the example of my project, which is the temperature and relative humidity instrument. So this temperature and relative humidity instrument using the ESP8266 over there. Okay, so this is the NodeMCU, and then it's being connected to the 5 volt of the USB cable over here, and then it's utilizing the HTU21D temperature and humidity sensor together with the OLED display over here. So let us have a look about the layout. So the layout are very straightforward. We have the ground, VCC, SCL, and also SDA. So this is the I2C communication. So the I2C communication for the SDA and SCL are being connected directly to the D2 and also the D1, where the D2 is actually dedicated for your SDA, and then the D1 is for your SCL, together also with this HTU sensor. CL is actually for the SCL, DA is actually for the SDA, and then you have here is the VCC and also the ground of the sensor. So the code of this deployment is very simple, and then I'm yet to find a very suitable casing for this project, and I'm using the standard Arduino Uno casing, if you can see over here, and then it's a DIY version, of course. And then it's only required 5 volt, and then the SDA and SCL need to be regulated with a 3.3 volt, which is, as you know, the NodeMCU capable of doing so. So this is the ESP826612E, a standard NodeMCU. So what else that you need to taking care of is basically when you attaching the wire over here. If you can see, I have the wire of the D1. So I'm also using the JST connector. So the JST connector is actually one of the way to connect the sensor with this connection. The reason of using the JST micro or any JST also will do is basically to replace any broken sensor in the future. Let's say that we have a broken sensor because of the unfortunate event and so on, and we also want to change the sensor to more high accurate sensor or any other modules, so we can do so if we got the standard micro JST connector over here. So that is the purpose of connecting the wire from the ESP module, NodeMCU Amica model over here, with the JST connector. So if you can see over here, the SDA SCL is actually attached to the green and also the black color of this wire. So the green and the black color of the wire is actually go to this. Okay, you can see the green color over here is SDA. SDA is the orange color. So the orange color is actually being soldered at the D2. So as I mentioned just now, the SDA go to the D2, and then the SCL, the black color over here is actually navigate through the actually attached to the yellow, sorry. So this is the D1. So the SCL is for the D1. Okay, this is the D1, and then this is the D2. SDA is D2, SCL is D1. So I also make the similar approach by changing the module here from the ESP8266 to the ESP32, and then it works quite well. However, in my experience, I would say that connecting the NodeMCU is much more easier and much more robust in terms of ensuring the connectivity with your Wi-Fi. So you can see over here the temperature is quite warm, and then the humidity also quite high because my room is not equipped with any air conditioning system at the moment, and also I did not turning on any fan nearby to avoid any disturbance. Okay, so that's all for this project. Hopefully I can share the makeup of this project. Just bear in mind that this NodeMCU is actually coming with the header pin, and then this is how I remove the male pin headers over here by just desoldering everything at the back so that it become flat. And then perhaps I can share with you the other ideas also. So you can also use the NodeMCU version 3. So this is the NodeMCU version 3, which is also capable of delivering the same thing. You can see over here we will connect it with the D1 with the SEL, and then the D2 with the STA. So this is a very nice looking board for the Wi-Fi or IoT project. And then I also have the ESP32. So this is the another component, which is, if I can zoom it a little bit, you can see the chip over there. So this is the ESP32 module. Okay, so this ESP32 module is also equipped with the JST connector for the power, which is the LiPo battery over here. And then it's also regulate 5 volt that you can use inside the model like this. So in a nutshell, the project is successfully delivered. And then I'm going also to discuss with you about how we can program it so that the data over here that you can see on the OLED display are going to be sent to the Thingspeak server. And then after that, we can make further analysis with regard to the temperature and humidity data that we already captured from the sensor. So until then, please have a look into the code, and then if you find out that this video is very useful, please do consider like, share and subscribe. I'm going to reverse engineering this project soon, so please check it out, and see you again next time. Thank you and bye bye.